Hello everyone, today I will discuss revision video 6, and in this video first 11 lecture of the content which are given to us will be discussed. Important concepts will be discussed only. So first video consists what is the AI and history of AI, agents of AI. So basic definition: artificial intelligence is a discipline which involve all sort of mechanism and algorithm that deal with mimicking the activities of brain. So there are numerous number of definition of AI, so you can correlate. And now what is the AI history? So in 1960, in 1936 and 37, Allen universal Turing machine was proposed. Important from exam point of view: 1942 and 1943, Von McCall and Walter Pitt created a computational model for neural network called threshold logic, and most probably it is also the part of assignment question. 1950 Turing test was proposed, not so much important. 1955, John McCarthy, founding father of AI, who's proposed coined the artificial intelligence first time in 1955, and first perceptron model was developed or introduced in 1957. This is very important. In 1960, genetic algorithm came into existence. 1965, fuzzy logic and deep learning. 1970, evolutionary computing. So in 1980s, neural computing, swarm intelligence. In 1990s, hybrid model like neurophagy, genetic, etc. Beyond 1990, some adaptive system came into existence. Evolutionary computing, very important, and data mining, simulated annealing, PSO, deep neural network, and so on. These are all came into existence after 1990. So what are the various agents of artificial intelligence? And it is very important. Agents of artificial intelligence: fuzzy system, artificial neural system, and evolutionary system. All these are the agent of AI. And basically evolutionary algorithm, genetic algorithm, differential evolution, meta-heuristic, swarm intelligence, and clone optimization, B algorithm. All these are the part of evolutionary system. Harmony search, firefly algorithm, PSO, artificial immune system. Next agent of artificial intelligence is the probabilistic system, which having Bayesian network and Gaussian mixer model. Next, chaos theory, simulated annealing, rough set theory, and sport vector machines. All these are the agents of artificial intelligence, and it is also being asked in the assignment question. What is computational intelligence? Definition we must know. Computational intelligence is a set of nature-inspired computational methodology and approaches to address complex real-world problems to which mathematical or traditional modeling can be useless, or a few reasons the process might be too complex or for mathematical reasoning. So it might contain some uncertainty during that process, or other process might simply be stochastic in nature. So major constituent of computational intelligence are fuzzy system and neural network, and last one is the evolutionary algorithm, and after that it is a hybrid intelligent system. So this is the basic structure of AI MLDL. This is artificial intelligence, a broad term, which under it machine learning is a subsystem, and again deep learning is a subsystem of machine learning. So we must have know this diagram. Artificial intelligence. So what are the field of artificial intelligence? So like computer vision, natural language processing, information retrieval, information filtering, predictive analysis, decision analysis, and robotics. And these are the applications, and it may be possible one question from this slide may be asked in final examination. And artificial intelligence, computer science, natural science, engineering, mathematics, statistics, we must to know about this field. so that we can apply or design and development of a specific application in respective field and for a specific application. So now fuzzy system theory. Professor Loptijade proposed the idea of fuzzy logic in 1965, and this is the Professor Loptijade. Differ computing from conventional, involved soft or partial truth, that is partial false or partial truth, deal with uncertainty due to ambiguity, imprecision and vagueness in the data, and it is a multidisciplinary area. Fuzzy set theory. There are various types of logic available, that is bivalent. In bivalent logic, truth is bivalent, implying that every proposition is either true or false, that is yes or no, 1 or 0, that's all. There is only two options, true, false, yes, no, 1, 0. In multivalent logic, truth is a matter of degree. In this there are multiple options will be available, which confined to degree of compatibility, right? So fuzzy logic deal with, fuzzy logic deal with this partial, a matter of degree of information, imprecise, approximate information, granular or linguistic information, perception based information, right? So these are the on which fuzzy logic deal. So little historical background of fuzzy logic. Classical logic of Aristotle was proposed in 400 BC, law of bivalence, which in use for more than 2000 years, right? Every proposition is either true, intermediate or false, like, and Jan Lukavics proposed three valued logic in 1990, and this is also the question which was being asked in the assignment. Jan Lukacs proposed three valued logic in 1900, true, false and possible, right? Loptijade proposed in 1965, popularly known as the fuzzy logic, a multi-valued logic. Fuzzy set theory logic is much more general than traditional logic system. Fuzzy logic provides a foundation for the development of new tool for natural language processing, like computing with the words, etc. So Boolean versus fuzzy. Aristotle came up with us the binary logic. So there are binary logic, and that is true, false, 0, 1, which has been principal foundation of conventional mathematics, right? So Boolean logic states a glass can be full or not full, right? Suppose a glass was only halfway filled, which means glass can be half full and half not full. This disapprove Aristotle law of bivalence logic, right? This concept of certain degree or multivalence is the fundamental concept stated by Professor Loptijade, professor in electrical department of University of Berkeley, San Francisco, USA. So as the complexity of a system increases, it becomes more difficult and eventually impossible to make a precise statement. Definitely, if the complexity of a system very high, then it is impossible to make a precise statement about its behavior, eventually arriving at a point of complexity where the fuzzy logic method born humans is the only way to get the problem. So this is the statement given by Professor Jade. Professor Loptijade claimed that many sets in the world surrounded by us are defined by a non-distinct boundary. There is no precision, or we can say uncertainty. Why should we use fuzzy logic system? We have to use fuzzy logic system in the following cases. System with imprecision, randomness and approximations, right? Uncertainties due to vagueness, ambiguity and partial truth, and one is black box or gray box. So this is also part of assignment. Why should we not use fuzzy logic? In the following cases, we must not have to apply fuzzy logic if we are sure that there are no uncertainty due to vagueness, imprecision and ambiguity represent. White box model, right? In black box model we have to use fuzzy logic, but in case of white box model we don't have to use. Linear system, we don't have to apply fuzzy logic. System with moderate non-linearity. If system is not so complex and linearity is up to the mark, then we don't have to apply fuzzy logic. System with moderate complexity. So these are the cases where we should not apply fuzzy logic. So video 2, as per the content, real life application of fuzzy system, right? First of all, in 1988 Hitachi turned over control of a subway in Sendai, Japan to a fuzzy system. This is perhaps the most visible application of fuzzy logic in the subway system. We can use in washing machine, fuzzy auto controller in car, fuzzy control in a cement kiln. If oxygen percentage is high, temperature is low, then increase airflow. Like if oxygen percentage is high and temperature is high, then reduce the coal feed rate slightly. In elevator system, in fuzzy in copy machine. So these are the numerous applications. In palm top computer, golf diagnostic system, in celerity in the codes, in image processing, condition based monitoring of machine, fuzzy logic in aerospace. So these are the application. In psychology, in air condition, recipe recommendation, automatic gear selection as per the condition of road, diagnosis of coronary artery diseases in agriculture. So these are the various domains. So now, what is fuzzy logic and what is the probability? Both operate over the same numeric range, and at the first instance both have similar value between 0 and 1, right? However, there is a clear distinction between the two, right? The semantic difference is significant as the first is based on degree of randomness, right? Fuzzy, whereas the second on degree of belongingness. So probability is degree of belongingness and fuzzy is degree of randomness. So like this is the case of fuzzy logic, tall, medium, short. So this is tall, and this is the case of short. But if you can see, this is the lady, and we are not so certain whether we have to put into tall or medium. So the type of some fuzziness will be there. But uh, when we use a coin and let it suppose for 10 times we coined, so head came into 6 times and tail came into 4 times, therefore probability of head to be appear 6 by 10 and this. So this is the basic difference between fuzzy logic and probability. So this is the basic concept. Input from the real world, measurement or assessment of system conditions like in temperature, market data. This will be input and comes into the fuzzy model, and after that it process that real time data and crisp output to be used as control signal or decision, right? And what is the fuzzy model? This is the detailed version of fuzzy model. So crisp input can be crisp or fuzzy, not issue. After that fuzzy fire, fuzzy inference engine, fuzzy rule base, defuzzifier, and crisp output, right? I already discussed in these things in detail. So fuzzy set. So if I look at the definition, so I will go with the definition only. A fuzzy set A can be written as a set of ordered pair. So this is very important, ordered pair of the element and its belongingness or membership in the set A. Fuzzy set representation, how it can be represented? So A is a fuzzy set, capital X is a universe of discourse. So therefore fuzzy set A can be written as, this is the degree membership, this is the degree of compatibility, right? Or this is the element x1 in fuzzy set A and so on. So it may be, and for the continuous and infinite universe of discourse, this will be our formula. A is equal to fuzzy set integration mu Ax upon xi, right? This is the example how it can be represented. Let X is equal to Delhi, Agra, Mumbai, Kolkata, Kanpur, IIT Kanpur be universe of discourse X. With place one may choose to live in and a fuzzy set A represent desirable place to live in. So A is the fuzzy set, and if anybody stay in Delhi, the degree of compatibility or membership value is 0.9, so very high, because it indicate that Delhi is very safe, and all the advanced infrastructures are available. Agra 0.6, Mumbai 0.7, Kolkata 0.7, Kanpur 0.1, IIT Kanpur 1. So from this fuzzy set we can say out of Delhi and IIT Kanpur is one of the best where we can live. Right. The same fuzzy set A can be here also be represented as like this. First 0.9 membership value and oblique Delhi. So this is the way to write, and also we can write in this way also. So with the help of example, this is on this. What criteria we should follow to choose membership? Nature of the variable, right? And resolution, oil level of detail to be included, nature of application, design and optimization stability, concept to represent the variable. So these are the main important parameter which we must have to take care. So membership function. So membership function lie in the range 0 and 1. Okay, and if it is membership value is 0 means no membership, and if 1 it is a full membership. So normally a fuzzy set is represented as, so a membership function can be any kind of function whose value remain bounded in between 0 and 1, right? So a fuzzy set is an extension of a classical set, right? So if X is the universe of discourse and its element are denoted by X, then fuzzy set A is given as this one. So already discussed, not a big deal. Now list of membership function. So these are the various list of membership function available. Just I will go with one by one, which is important, and some assignment questions already we covered in our assignment. So triangular membership function, what we have to take care? We have to take care about this formula. It may be asked in the final examination. So in a triangular membership function, there are three parameters, right? So we have to take care about three parameters, right? So A, B, C, and this is the formula. Another way to represent this is this one. Next, trapezoidal. So in trapezoidal, membership function is specified by four parameters, right? A, B, C, D, right? And this is the formula. And in another way we can also write this. Gaussian membership function, very important. We have to take care about this particular formula, and there are only two parameters in it, that is C and sigma, right? C represent the membership function center and sigma determine the membership width, right? So this is equal to e raised to the power minus 1 by 2 x minus c upon sigma whole raised to the power 2. Generalized bell. A generalized bell-shaped membership function is specified by three parameters, that is A, B, C, and this is the formula for this one. Now, in the final examination, the main important concept in this case, what represent A, B, C, right? A define the width of the membership function, right? Width like this. So this is the width. And that is larger value creates a wider membership function if value of A is large. B define the shape of the curve on the either side of the central plateau, right? This is the center, so this define the shape of the curve on either side of the central. C define the center of the membership function, and C define the center, so we have to take care. C is the center, A define the width, and B define the shape of the curve on either side of the central. The sigmoidal function is given by xac. So there are only two parameters available, 1 upon 1 plus e raised to the power minus a x minus c. The magnitude of a control width of the transition area, right? So A control the width and C define the center of the transition area, as in the case of in last there are three parameters A, B, C. A represent the width and C represent the center, right? So in the same way we have to take care. Left right membership function. So a left right membership function is specified by three parameters, right? So alpha, beta, C. So this is the formula, and in this is also important. C define the point where the value of membership function is 1. Okay, C where membership function value is 1. Alpha control the width of the left region, so this is important. Alpha control the width of the left region. Beta control the width of the right region when x less than equal to C and when x greater than C. So we have to take care. Pie shaped membership, this is also question available in the assignment, and there are two important parameter in it. So the first pi membership function is defined with two parameter, right? So two parameter AB. So we have to take care about this formula. And another formula for this is there are four variable pi membership function. So we have to take care about this. So parameter LW and RW define the feet of the membership function. Very important. LW and RW represent the feet, and LP and RP both represent the its shoulder, right? So pi membership like this. So LW and RW define the feet, the feet, and LP and RP define the shoulder. This membership function was used to define the fuzzy set good stopping accuracy, that is Sendai subway train control system. Open right membership function. So because from the left side it is closed, but from right it is open. Therefore when x greater than beta, membership value is equal to 1, and from this to this range membership value is this one, and if x less than alpha, membership value is equal to 0. In the same way, open left, so it is openly from the left, and from the right it is closed. So this will be the formula. S-shaped. So S-shaped membership function by defined by two parameter. So these are the two parameter A and B as for, and we have to take care about the formula. Parameter A define the feet of the membership function, and B define its shoulder. Okay, so we have to take care. So right now nomenclature used in fuzzy set theory. So there are total 15 nomenclature used in this. I will go with this. Sport. The sport of a fuzzy set is the set of all point x in universe of discourse x for any associated member function. If there is any element in fuzzy set and whose membership value greater than 0 is known as the sport, right? If there is any element, let x1, and whose membership value is 0.01, then it is part of sport. That's it. So this is the basic definition. Core. In the core, membership value must be equal to 1. So this is the core where the element having the membership value is equal to 1. That's it. Crossover, when the membership value is equal to 0.5. So these are the 2 point in this membership function, triangular membership function, where the membership value is equal to 0.5. So in case of crossover, membership value must be equal to 0.5. With help of example, we can easily see that. Height of a fuzzy system. So the height of a fuzzy system is the maximum value of the membership function. In this case, height is 1. In case of C, height is 0.75. In case of B, height is 0.4. So this is the height. Normality. Normality, a fuzzy set is said to be normal if its core is non-empty. Its core is non-empty means there is any element available which having the membership value 1. means if there is any element in the core, then definitely its membership value will be equal to 1. So definitely a fuzzy set A is normal, definitely it means membership value is equal to 1. Normalization of a fuzzy set. So this is the fuzzy set because it is not a normal fuzzy set because membership value is zero point 0.7. We have to make it a fuzzy set, a normal fuzzy set. So what we have to do, we have to divide it by with the membership value 0.7. After that it becomes normal fuzzy set. So this becomes this. Fuzzy singleton, there is any single element available in that fuzzy set and whose membership value is equal to 1 is called fuzzy singleton. So a fuzzy set whose support is a single point, उसका support क्या होगा, एक single point होगा, and in for that particular point membership value is equal to 1. Alpha cut, right? So there is a two alpha cut and strong alpha cut. In case of alpha cut, membership value must be equal to this particular value, right? Alpha. I already discussed in assignment. Not I will go with the in detail. So in case of strong alpha cut, it must be greater than alpha. But in case of alpha cut, it is greater than equal to alpha in case of alpha cut, but in case of strong alpha cut it must be greater than alpha. So convexity, so this is very important. A fuzzy set A is convex if and only if this condition is satisfied. Mu A lambda x1 plus 1 minus lambda x2 must be greater than equal to minimum of mu A x1 mu A x2. So alternatively A is convex if all its alpha level sets are convex. So these are the cases: strictly monotonically increasing, strictly monotonically decreasing, strictly monotonically increasing, then strictly monotonically decreasing with increasing value of element in the universe of discourse. So with help of example you can say this. So it is strictly increasing and after that strictly decreasing, but in this case first it is increasing, then decreasing, again increasing and again decreasing. So that's why it is not follow the property of convexity, it's follow the property of convexity, right? Nomenclature convexity, it is also important. If a special property of convex fuzzy system is that intersection of two convex, this is the convex system and again this is another a convex fuzzy set and intersection of it also becomes to the convex. With help of example we can determine all these things. A fuzzy set A is given for universe of discourse sense, find out the whether A is convex or not. So with the help of that 0.1, 0.6, 0.4, 0.5, 1, 0.9. So first it is increasing 1, 0.4, 0.5, 1, again decreasing 0.7, 0.3, again it's increasing 1, right? So that's why it's don't follow the property of convexity. Nomenclature using cardinality. A crisp set, the cardinality of a fuzzy set is measure of the number of element in the set. Like for example, a fuzzy set having 5, 10, 15, 20, these are 4 elements, so the cardinality of this is 4, right? In case of a fuzzy set and if it is a continuous fuzzy set, the cardinality is infinite, but it is the case of continuous. Let us, this is the case, this is the example, and we want to know the cardinality of ABC fuzzy set. Just we have to count the element, how many elements are available, that is equal to the cardinality of that particular fuzzy sets. So fuzzy number, so this is the part of fuzzy number. A fuzzy number A is fuzzy set, so whatever be a fuzzy number, that must be a fuzzy set in the real time that satisfy the condition of normality and convexity. So this is not the case of a convexity, therefore this is not a fuzzy number. So fuzzy number, this is fuzzy number, right? And this is also a fuzzy number. fuzzy set A and B are both normal and convex, but fuzzy set is convex but not subnormal because its membership value is not equal to 1. That's why it is not a fuzzy number, because its membership value is not equal to 1. Bandwidth, the difference between these are known as the bandwidth. For a normal and convex fuzzy set A, the bandwidth or width is defined as the distance between the two unique crossover point. So this is the crossover point and this is another crossover point. The difference between them is known as the bandwidth. So fuzzy symmetry, so this is a membership function symmetric about C1. This is another fuzzy membership function trapezoidal, which is symmetric about C2. Open left and open right already discussed, not a big issue. Set theoretic operation on a fuzzy set. Normally these are the following sets which are following operation which are operated on fuzzy set: complement, union, intersection, difference. So I will not discuss all of this, just I will discuss only the difference, because complement, union, intersection are very easy. Fuzzy set notation: so X belongs to universe of discourse, X belongs to fuzzy set A, X don't belongs to fuzzy set A subset of B, A subset or contained in B and equivalent to B. So A contained to B, so A is equal to B. A is equivalent to B means it's a subset of B or B subset of A. Phi null set. So these are the simple notation which are used in fuzzy. So before introducing the set theory operation, we must know about the equality and containment or subset, right? So mu ax, fuzzy set A is equal to fuzzy set B when all the membership value of corresponding element are equal, then only it will be equal to, or we can say equality. Containment means A is the smaller fuzzy set and all the membership value must lie in the fuzzy set B. So with help of example we can show it very easily. Video 11, following operation on fuzzy set: complement, union, intersection. You have to take care yourself. I will go with the difference only, right? So how we will calculate it? So difference A minus B, so minimum mu A and mu B complement, and for B minus A it will be equal to mu minimum of mu B and comma mu A complement. So this is the question, that we are having two fuzzy set A and B, right? And the membership function is the membership function for the different set A, B. What we have to calculate? We have to calculate in this case mu B bar. So B bar will be equal to this, just we have to take care the complement, right? After that A difference B, so we have to consider this particular 0.61 and for A 0.71. So minimum of these is 0.6, therefore we have to consider 0.6. Next, for fuzzy element 2, 0.1, in this case 0.5. So minimum value out of this is 0.1, therefore we have to consider this one. So in this way we can calculate the difference. Thank you so much, and next video in which I will discuss 10 more videos which will be very helpful in the final examination.